In questo video parleremo del primo articolo che abbiamo pubblicato. Come vedete la firma non è solo la mia, in cui compare per la prima volta la Dn constant. A Number Theoretic Analysis of the enthalpy energy density, thermodynamic volume and the equation of state of a modified white hole and the implication to the quantum vacuum spacetime, matter creation and the Planck frequency. In this paper, we analyze the enthalpy energy density, thermodynamic volume, and the equation of state of a modified white hole. We obtain new possible mathematical connection with some sector of number theory, Ramanujan Recurring Numbers, Dn constant, and string theory that enable us to extract the quantum geometrical property of this thermodynamic equation and the implication to the quantum vacuum spacetime geometry of our early universe, as they act as the constraints to the nature of quantum gravity of the universe. The geometric structure of quantum gravity has been established to be discontinuous, and other theories of quantum gravity, like loop quantum gravity, consider the quantum geometry to be in the form of loops, while string theory considers quantum geometry to be in the form of strings. We shall observe that the results of the analysis of this paper, based on the work of thermodynamic constraints of a modified white hole, encompass the form of quantum geometries as predicted by these two promising theories fundamental of physics. Precisely, it is shown that a full picture of a complete quantum vacuum geometry is a combination of the two quantum geometry. A full connection between the two quantum geometries is found through a number theoretic properties of the constraints of the thermodynamics of the modified white hole. The quantum vacuum geometry picture we found indicates a clear depiction of the gauge bosons and the scalar boson supergravity lattice and how they are related and arranged in relation to big graviton, which through the analysis suggests that it might not be a gauge boson, but an independent quantum geometric force carrier as discussed in reference 5. This then shows that in the final analysis, the quantum vacuum geometry that we derive is fundamentally as it sheds some light of matter creation facilitated by the Higgs scalar boson from supersymmetric vacuum quantum geometry through to symmetric breaking at the moment of Big Bang and into the well-known mechanism of matter formation moment after the Big Bang. Our paper is structured as follows. Sections I and B, we analyze and list the number theoretic properties and the Ramanujan recurring number properties of the fundamental thermodynamic quantity of the modified white hole in the presence of a cosmological constant at extremely low entropy. Then, in section C, we apply these properties to quantum gravity, and in the process we get a picture of the nature of the quantum geometry of the modified white hole in terms of the octahedrons and a sphere. And we show that this quantum geometry has the properties of quantum strings and Brownian instanton. In section D, we illustrate the theoretic number connection to Planck multiply spectrum frequency and to the hypothetical gluino mass. Section A. Analysis the equations of the modified white hole enthalpy coupled to quantum Bose-Einstein condensate at extremely low entropy. The equation to be analyzed in this section in this section are from paper by reference 4. Analysis of the enthalpy of the modified white hole. The enthalpy of the modified white hole is given by the following equation. We analyze the number theoretic properties and the Ramanujan recurring number properties of the enthalpy equation 1 as follows. Exact result. The exact result of the enthalpy equation 1 is the following, which has the alternate forms. The alternative forms, equation 3, 4 and 5, has the following expanded form. Assuming A, B and S are positive, the alternative forms are 7 and 8, from which we obtain the expanded logarithmic form as equation 9. And assuming that S is measure of the 0, the square root of S on the square root of pi is measure of the 0, and S on the pi minus by multiplied square root of S on the square root of pi equal to 0, then we get the alternate form and its derivative. With regard to the indefinite integral equation, the above equation has the following indefinite integral. From which we obtain the following alternate forms. Assuming A, B and S are positive, then the alternate forms are 1, 2, and 3. The expanded logarithmic form of the alternate forms equation 17, 18 and 19 are then given by the following equation, the following expression. And assuming the following condition, then we get the alternate form and then its derivative. Alternate form and its derivative. With regard to the indefinite integral, we obtain the indefinite integral of the above equation as the following, which has the alternative forms 1, 2, and 3. This equation has the expanded form as the following expanded form, 27, equation 27. And assuming A, B and S are positive, then we obtain the alternate form, which has the expanded logarithmic form. And again, assuming the following condition, Then we get the alternate form, which has the following derivative. Again, the indefinite integral from the equation 51. The indefinite integral of the equation 51 is the following. Now, with regard to the volume analysis, because of supersymmetry of space at extremely low entropy, then it is therefore possible to consider the vortices of the quantum vacuum schematized as cubes or octaedron loops. We also assume that the quantum van der Waals fluid, see reference 4 and 6, are characterized by smooth spheres. In reality, the quantum vacuum will have n-dimensional hyperspheres, in which the compactified dimensions roll up and octaedrons representing the fluctuation containing vibrating quantum van der Waals fluid particle. Therefore, for volume equal to therefore, for this volume that is equal to the octaedron volume, and for this volume that is equal to the sphere volume, where R equal to A on 2, we get the following. With regard to the octaedron volume, from the indefinite integral equation 52 above, we obtain the following exact result, which has the alternative forms 1, 2, 2, and 3. Choose from the indefinite integral equation 52, we obtain the following exact results and the following alternative forms 1, 2, and 3. The expanded form of the above equation is the following, and assuming A, B, and S are positive, we obtain the alternate form of the above equation as the following expression, which has the expanded logarithmic form given by the following equation. The alternate form of this equation is the following, and its derivative is given by the following equation, following expressions. This is the result of the derivative, the result of the derivative result. Okay. The indefinite integral of the 41 equation of the above equation is then given by the following expressions, and the indefinite integral result is the following. With regard to the sphere volume, from the indefinite integral equation 52, we obtain the exact result, which has the alternate forms 1, 2, and 3. And the expanded form of these three equations are given by the following equation. Now, assuming that I, B, and S are positive, then we obtain the following alternate forms with the expanded logarithmic form. The alternate form of the equation 49 is the following expression with the following derivative at the following indefinite integral. Derivative and indefinite integral. Number theoretic properties of the volume. Dn constant, del Gaudian-Ardelli constant. Now, dividing the two indefinite integral results for the octaedron and the sphere volume, equation 42 and equation 52, respectively, we get the following integral and the following integral, which simplifies to the exact result, of which the expanded form is the following, with the alternative form 2 multiply square root of 2 on pi, that is equal to the following decimal result, which is at the Dn constant, del Gaudian-Ardelli constant. The properties of the function has an even parity, indefinite integral, global maximum, okay, global minimum, and this limit. Again, the series representations. When n is the factorial function, this is the Poisson symbol, resigning factorial. This is the set of the real numbers. This is the complex argument, and this is the floor function, and E is the imaginary unit. With regard to the definite integral over a disk of radius L, we obtain the following definite integral that is equal to 2 multiplied the square root of 2 multiplied then the definite integral over a square of edge length equal to 2 multiplied L is the following, and this is the result. We have time two definite integral. One definite integral over a disk of radius L that is the following, and that is the result. And that is the result. And this is the result. Sorry. And this other integral, and that is equal to the following result. Okay, one definite integral, the first definite integral, and the second definite integral. This definite integral over a disk is equal to the following result, and this second definite integral over a square is equal to the following result. Analysis of the thermodynamic volume of the modified white hole. The thermodynamic volume of the modified white hole is given by the following formula. The analysis gives the following number theoretic properties and the Ramanujan recurring number properties of the thermodynamic volume. Alternate forms. The thermodynamic volume equation, above equation, has the following alternate forms, practically. This form and this other form. this alternate form and this other alternate form. Assuming A, B and S are positive, then the alternative forms equation previously equation becomes the following expression, and the derivative is the following. The indefinite integral is then given by the following expressions: the integral and the result, the derivative and the result. Dividing the alternate form equation 69 by the following expressions, we obtain the exact result 75. Equation 75. With regard to the volume analysis, from the exact result above, from the above exact result, practically the 75 equation, and with the octahedron volume and the sphere volume, where R equal to A on 2, we obtain respectively, with regard to the octahedron volume, the following exact result. With regard to the sphere volume, the following exact result: 1 and 2. Number theoretic properties of the volume. By dividing the two exact results, practically the above two equations, 76 and 77, and simplifying by making the following input, we obtain again the following result: 2 multiplied square root of 2 over pi. That is equal to the following decimal approximation: 2 multiplied square root of 2 over pi, practically the Del Gaudian-Ardelli constant, which is the Del Gaudian-Ardelli constant, and also 2 multiplied square root of 2 over pi has property that this is a transcendental number. The transcendental numbers have important properties in physics and in particular in astrophysics, particle physics and cosmology, because they allow us to reformulate and resolve unresolved problems, and in our case, the geometry of quantum gravity of the very early universe. See reference 7. The series representation of the Del Gaudian-Ardelli constant is the following: 1, 2, and 3. Now, analysis of the enthalpy energy density of the modified white hole. The enthalpy energy density of the modified white hole is given by the following equation. And dividing the exact result equation 2 by the alternative form equation 69, we obtain the following expressions or formula. Then the analysis gives the following number theoretic properties and the Ramanujan recurring number properties of the enthalpy energy density. The exact result is the following, and for S equal to about 4 pi, we obtain the following expression, which has the alternate forms 1, 2, 3, and the alternate forms equation 186, 187, 188 have the following expanded forms, with the expanded logarithmic form. Which has the alternate form and the root for the variable b is equal to the following expressions. With regard to the indefinite integral for the alternative form equation 91, practically this equation, this alternate form, the indefinite integral is the following: integral and result, from which we obtain the following alternate forms: 94, 95, 96. 1, 2, 3. The expanded form of this above equation is the following expression: 97. Assuming A, B, and S are positive, then we have the alternative form 98, from which the expanded logarithmic form is the following. The alternate form of the above equation, particularly of this equation, is the following, with the roots that are the following: again, we obtain also the series expansions. The Taylor series expansion about A equal to 0 is the following, and the Laurent series expansion about A equal to 0 is the following. We obtain the Taylor series expansion and the Laurent series expansion about A equal to 0, 1 and 2. The derivative of the alternative form of the previous equation, practically of this equation, the derivative is the following, with the indefinite integral given by the following expression. Taking the limit of alternative form, equation 100 as b tends of infinity plus or minus, we obtain this limit equal to 0. And for the octahedron volume and the sphere volume, where R equal to A over 2, we obtain the following respectively. Octahedron volume. For the octahedron volume, we have the following expressions. And plotting this result, we obtain the following three-dimensional and the contour plots that can be related to a de Bruijn instanton. This is for the octahedron volume, we have the following formula and the following three-dimensional and contour plots that can be related to a de Bruijn instanton. The K observation from figure 1 and figure 2, and as confirmed by reference 4, is that at A equal to 1, which is taken as the energy density of the universe at the Big Bang, with B equal to 0, the zero spacetime volume, the vacuum geometry, breaks, or there is symmetry breaking on the vacuum quantum geometry. We see from the plots as the vacuum spacetime break tear apart. Continuing further, we obtained the following properties of the equation 107, that the alternate forms are, this is the picture, the picture, the 3D plot, the three-dimensional plot. 1, the contour plot, the alternate forms are the following: 1, 2, 3. And the expanded forms of equation of the above equation as the following. Okay, this is the plot. Okay, plot and the contour plot that can be related to a de Bruijn instanton 1 and 2. The expanded forms of the following equation are the following expression. And assuming A, B, and S are positive, then we have the alternative forms from which the expanded logarithmic form is the following. With the alternate form, that is the following. Again, the roots of the alternate form equation 114 are the following. Furthermore, the Taylor series expansion about A equal to 0 is the following. And about A equal to infinity is the following. The derivative of the alternate form equation 113 is the following, the derivative and the result, and the indefinite integral is the following. With regard to the sphere volume, we have the following formula. And similarly, plotting this result, we obtain the following three-dimensional and the contour plots that can be related to a de Bruijn instanton. The observation in figure 3 and figure 4 is the same as in figure 1 and figure 2. Continuing further, we obtain the following properties of the equation 120, that the alternate forms are, this is the plot as the previously, with the dimensional plot as the previously, and this is the alternate forms, from which the expanded forms are the following. Alternate form, expanded form. Assuming A, B, and S are positive, the alternative forms are the following, and choose the expanded form is the following, from which the alternate form is the following, with the following roots. The Taylor series expansion about A equal to 0 is the following, and about A equal to infinity is the following. The derivative of the alternative form equation 127 is the following, and the indefinite integral is the following. The ratio of the octahedron volume to the sphere volume and its number theoretic properties. Taking the following limits, and choose the dividing octahedron volume equation 107 by the sphere volume equation 120 and simplifying by the following factor, we obtain another time the Gaudian-Ardelli constant with the following decimal approximation. And as we note that it is also a transcendental number as well. It has the following series representations: 1, 2, and 3. Now, analysis of the equation of state of the modified white hole. The equation of state of the modified white hole is given by the following equation. The analysis gave the following number theoretical properties and the Ramanujan recurring number properties of the equation of state. The exact result is the following. Considering s equal to 4 pi, we obtain V to be this equal to this expression, which then simplifies to this equation, which when we plot it, get the three-dimensional and the contour plots below that can be related to a de Bruijn instanton. From figure 5 and figure 6, we note that the gravitational potential is almost zero as the self-vacuum perturbation haven't started to take effect, resulting in the flat quantum vacuum geometry. The alternate forms of equation 142 are the following, the alternate forms, which have the expanded logarithmic form. This figure are the three-dimensional plots. Number theoretical properties of the equation of state with regard to the roots from which the alternate form, and the roots are the following. The polynomial discriminant is the following, and the integer root are the following. Choose the derivative of the alternative form. Equation 147 is the following, while the indefinite integral is the following, which when we plot it, get the three-dimensional plot that can be related to a de Bruijn instanton, and we also plot its contour plot. From figure 7 and figure 8, we also observe that the vacuum quantum geometry starts to be uneven, meaning the seeds for the gravitational potential are starting to take effect due to the self-perturbation starting to take effect. The alternate forms of indefinite integral equation 115.3 is the following. The alternate forms are the following. This is the above three-dimensional plot that we have and obtain. And assuming A, B and S are positive, then we have the following alternative form, from which the expanded logarithmic form is the following. From the expanded logarithmic form equation, the alternative form is the following, with the root and the polynomial discriminant that is equal to the following expression. And the derivative is the following, with the indefinite integral that is the following. From the above indefinite integral, we have the following three-dimensional and the contour plots that can be related to the de Bruijn instanton. From figure 9 and figure 10, we also observe that the vacuum quantum geometry starts to be more uneven than in figure 7 and figure 8. That is, the gravitational potential of the quantum vacuum geometry is growing as a result of the growth of the vacuum self-perturbations. This is the three-dimensional plot and the contour plot. The alternate forms of the indefinite integral equation 163 are the following. And assuming as usual A, B and S are positive, then we have the alternative form, and from this equation the following expanded logarithmic form. And again the alternative form, that is the following, with the root the following root. The polynomial discriminant is the following, and the derivative of the alternative form equation 169 is the following, and the indefinite integral is the following. Also here the local minimum is the following at this condition. In conclusion, the indefinite integral result equation 172 and for octahedron volume and sphere volume, where R equal to A over 2, we obtain for the octahedron we have the following expression, which when we plot it get the three-dimensional and the contour plots that can be related to a Brownian instanton. From figure 11 and figure 12, we now observe that the vacuum gravitational potential has grown exponentially and infinitely high as a result of the exponentially grown and infinitely high ground to vacuum self-perturbation near A equal to 1, practically the energy density of the universe at the Big Bang. The alternate forms were found to be 1, 2, and 3, and the expanded form is the following, with the expanded logarithmic form that is the following. This is the three-dimensional plot and the contour plot. The alternate form of the equation 179 is the following, with the following root. The polynomial discriminant is delta equal to 0, and the derivative is the following. And this is the result, the derivative result. While the indefinite integral is the following, and this is the indefinite integral result. The local minimum is the following at this condition. With regard to the sphere volume, for the sphere we have the following expressions, which when we plot it get the three-dimensional plot that can be related to a Brownian instanton, and we also plot its contour plot, as in figure as in the previously figured. In case of the octahedron, here we also observe that the vacuum gravitational potential has grown exponentially and infinitely high as a result of the exponentially ground and infinitely high ground to vacuum self-perturbation near A equal to 1, practically the energy density of the universe at the Big Bang. The alternate forms of equation 185 are 1, 2, and 3. And assuming as usual A, B, and S are positive, then we have the alternative form This is the three-dimensional plot. This is the contour plot, from which the expanded logarithmic form is the following. The alternative form of the expanded logarithmic form is the following, with the following roots. The polynomial discriminant is delta v equal to 0, and the derivative is the following. From the indefinite integral from which we obtain the following minimum at this condition. By dividing the integral equation 183 with the integral equation 194, we obtain the dn constant, 2 multiplied square root of 2 over pi, with the following decimal approximation, which is the Gaussian-Ardeli constant and also a transcendental number. It is also the reduced logarithmic form. The alternative representations are the following. Where this is the base b logarithm integral n of x is the polylogarithm functions. With regard to the series representations, we have the following expressions. Now, we have the application of the formulas of the volumes of an octahedron and a sphere to quantum gravity. In this section, we apply the number theoretic properties of the Ramanujan and the Ramanujan recurring number properties to the quantum geometry of the white hole. With regard to a sphere inscribed in an octahedron, we have the following formulas. We take the ratio between the two above formulas for the octahedron and sphere in the above equation, as shown in figure 50. We obtain the del Gaussian-Ardeli constant, that is a transcendental number. The following series representation. This is the picture of the sphere inscribed in an octahedron, from which we obtain the following expression, that is equal to zeta 2, practically pi squared pi on the 6 over 6. Pi squared over 6, practically the value of the zeta 2, that is the following. Which is also the trace of the instanton shape and the Ramanujan recurring number. And also it is a transcendental number. The series representation of the above equation are the following, with the following integral representation. We note that from the sum of the first 9 numbers, excluding 0, we obtain the following interesting formula, where phi is the golden ratio. This is the Marvin-Rayburn constant. The exact result of the following equation is given by the following expression, that is in decimal approximation a result very near to the value of the zeta 2, practically pi squared over 6. The alternate forms for equations for the above equation, from this, the alternate forms of this equation is the following. Alternate forms 1, 2, and 3, from which the following expanded forms 1, 2, and making input the following expression, we obtain the exact results, which with decimal approximation is a result very near to the value of pi, which is a Ramanujan recurring number. The alternate form of this equation is the following, from which the expanded forms are the following. We have the following roots. Furthermore, from the following input, 2 pi multiplying square root of 2 multiply the ratio between the volume of the octahedron and the volume of the sphere equal to 8, where the value 8 is linked to the Ramanujan function, an elliptic modular function that satisfies the need for conformal symmetry, that has 8 modes corresponding to the physical vibration of a superstring. The series representation of this equation are the following: 1, 2, and 3. From the above equation, inserting 6 pi multiply square root of 2 multiplying the ratio between the octahedron volume and the sphere volume, we obtain 24. The value 24 is linked to the Ramanujan function, an elliptic modular function that satisfies the need for conformal symmetry, that has 24 modes corresponding to the physical vibration of a bosonic string representing the bosons. From the analysis, we observe that there is no number theoretic connection with physical vibration of fermionic strings at extremely low entropy. This fact is confirmed by the fact that the Higgs bosons at the moment of the Big Bang and infinitesimally shortly thereafter facilitated the creation of the fermions, matter and antimatter particle. See reference 8. Choose, we note that the ingredients for the formation of the electromagnetic radiation from photons, that is a boson, and the formation of matter from the Higgs boson after the Big Bang are intrinsic properties of the vacuum energy in pre-Big Bang. The series representation are the following. By the following input, practically the previous expression that is equal to 8, we obtain 4096. The number 4096 is the Ramanujan recurring number that, when multiplied by 2, gave 8192. The total amplitude vanishes for gauge group SO 8192, for bosonic string SO 8192, while the vacuum energy is negative and independent of the gauge group. The vacuum energy and the dilaton third pole to lowest non-trivial order for the open bosonic string, while the vacuum energy is non-zero and independent of the gauge group. The dilaton third pole is 0 for unique choice of gauge group SO 8192. This could be the implication for a pre-Big Bang scenario where only self-perturbative bosonic strings lived when the enthalpy was extremely low, as discussed above. This regime contains all the intrinsic properties of superstrings inherent in the bosonic strings that as observed by reference 10. All that the Big Bang gave effect to the proper properties of matter, fermions, as Higgs boson. This number theoretic connection to the gauge group SO 18192 gives a much more compelling relevance of the bosonic string theory SO 8192 to quantum gravity and place this string theory where it should appropriately be in the evolution of the universe from a quantum gravity perspective, rather than it be neglected because it doesn't include fermionic strings to confirm the post-Big Bang reality. The vanishing of the bosonic strings amplitude could be explained by the effect of extreme low entropy on the vacuum of the quantum vacuum geometry as discussed in reference 4. Choose as the entropy increases infinitesimally as a result of the vacuum self-perturbation, then also is the amplitude of the vibrating bosonic string from 0. See reference 9, was right to indicate that the vanishing of the amplitude of the bosonic string could be the result of string theory itself, but here we give a much more elaborate explanation of what could be happening. We further proceed and make the input the following expression. This result, 1729, is very near to the mass of the candidate gluable F0 1710 scalar meson. Furthermore, 1728, the mass of candidate gluable is F0 1720. Furthermore, 1728 occur in the algebraic formula for the J invariant of an elliptic curve. 1728 is equal to this product. The number 1728 is one less than the Hardy Ramanujan number 1729, that is a taxicam number, and also a Ramanujan recurring number. Since bosons are made of gauge bosons and scalar bosons, meson, then this number theoretic analysis perhaps confirms that the number 1729 confirms the fact that both the gauge and scalar bosons are actually different states of a single bosonic string, and that these states are isomorphic, or that the state's vibrations are synchronized with the state of the bosonic string. This also implies that each state lives inside a cubic or octaedron as a spherical cube, and that the total sum of these two states is the state of the bosonic string. Taking the cross section of the bosonic string, we realize that it must be a rectangular of a two-shaped octaedron. As the string vibrates in different frequencies, so is the two spherical cube states inside the string. That is, the string vibration simply excites the gauge boson, practically the photon, gluon, W and zeta inside one tube octaedron, and the scalar boson, practically Higgs, inside the other cube octaedron. Furthermore, if we bring the picture of loop quantum gravity with the property of a discontinuous quantum geometry, We can therefore think of the graviton living on the vertices of the rectangles or the octahedrons. This graviton then acts as glue binding the bosonic strings lattice together, forming a complete cross-section of alternating states of between the gauge bosons and the scalar bosons. This arrangement of states then gives a precise supersymmetric quantum picture of the vacuum geometry at low entropy. But the geometry further reveals a very important fact, that since the vacuum geometry is discontinuous, then we observe that there is no relation whatsoever between the quantum vibration frequencies of the strings and that of the vertices of the vacuum geometry where the graviton lives. As Steger and others asserted that gravity is simply a manifestation of spacetime geometry. Choose. The graviton cannot be a string boson. However, there is a duality between gravity and strings. See reference 11. Also, gauge bosons have spin 1, while the graviton has spin 2. Then, lastly, because of the thermodynamic constraints, we were able to arrive at the results we have. Now, this brings us to this fundamental question. That string theory and loop quantum gravity theory are two intrinsic aspects of a complete quantum gravity theory we are after. That is, without the other no complete and compelling quantum geometry can be attained as it is done here. This needs to be investigated further. The series representation of the previous equation are the following. We input the following expressions with a decimal approximation, which is the result that is a very good approximation to the value of the golden ratio, which is a Ramanujan recurring number. We have the following series representation. From impacting the transcendental number equation 213, we obtain the following expression with the decimal approximation is a result very near to the value of pi, which is a transcendental number. The series representation of the following equation are the following, and the integral representation are the following: 1, 2, and 3. It is plausible to hypothesize that pi and phi, in addition to being important mathematical constants, are constants that also have a fundamental relevance in the various sectors of theoretical physics and cosmology. From pi squared over 6, we obtain by the following formula. Again, the Gaussian are daily constant. The series representation of this formula is the following: 1, 2, 3. We note that from the number 8 we obtain as follows. In the above figure, the golden range number scale, we notice how from the number of 8 and 2 we obtain 64, 1024, 4096 and 8192, and that 8 is the fundamental number. In fact, we obtain 64, 522, 512, and 4096. We define it fundamental number, since 8 is a Fibonacci number, which by rule divided by the previous one, which is 5, gives the following value, that is a value that tends to the golden radius, as for all numbers in the Fibonacci sequence. Finally, we note how 64 multiplied by 27, to which we add 1, is equal to 1729, the so-called Hardy-Ramanujan number. Then, taking the 15th root of 1729, we obtain a value close to zeta 2, practically this value, which in turn is included in the range of what we call golden numbers. Furthermore, for all the results very near to 1728 and 1729, adding 164, one obtains values about equal to 1792 and 1793. These are values almost equal to the Planck multiple spectrum frequency, black body radiation, 1792 about, and to the ipotetical gluino mass. Questa praticamente è stato il primo lavoro in cui si è discussa e si è, diciamo, ipotizzata, proposta del Gaussian constant, quale possibile parte di un modello matematico. Come vedete, questo è un modello puramente matematico. C'è anche la fisica, ma è un modello principalmente matematico, sviluppato da me e dai professori Amos Kubeka e Alize Ramani. Ma principalmente si tratta di modello matematico. Quindi, come vedete, c'è una spiegazione a tutto. Mi si perdoni il pessimo inglese, La prossima volta al limite faccio un video in cui spiego lo stesso argomento in italiano, in modo che lo comprendete meglio. Però c'è anche la parte, ora che posterò il video su YouTube, metterò anche il link del lavoro, in modo che chi vuole può andarlo ad approfondire. Comunque, ripeto, è soltanto una proposta che sta avendo parecchie view e parecchi download, e questo non ci può che far piacere. Per il resto, che devo dire? Io proseguo su questa strada. I lavori e i video che avete visto fino adesso sono il proseguimento di questo lavoro, l'approfondimento di tale lavoro, sempre dal punto di vista eminentemente matematico. Lo scopo, almeno del sottoscritto, è quello di arrivare praticamente a un modello matematico di possibile unificazione delle forze fondamentali. E questa potrebbe essere la strada giusta. D'altronde anche Einstein diceva: la semplicità è la migliore cosa in questo universo. Può essere che un modello matematico abbastanza semplice, quale quello basato su come vedete su costanti quale φ, π greco, la stessa del Gauss-Nardelli constant, che non è altro che poi il rapporto tra il volume di un ottaedro e il volume di una sfera, potrebbe essere diciamo costanti chiave che intervengono nell'evoluzione e nella geometria dell'universo, insieme alla costante cosmologica, al tasso di espansione, alla costante di Hubble, eccetera. Questi sono parametri matematici, legati sia alla fisica, ma parametri matematici. Attenzione a non confondere le cose. Vi ringrazio per la pazienza, ripeto, abbiate pazienza dell'inglese, che ormai a 55 anni non è che sono più allenato come una volta, e vi auguro una buona serata. Grazie.